Good morning, everyone. This is Miss Francis, your teacher, and I am also the mathematics teacher at Inagua All Age. Today's panelists are Ms. Sturrup, Ms. Russell, and Mrs. C. Black, who will be assisting me with today's lesson by answering any questions you have. Remember to use the question and answer tab if you have any questions pertaining to today's lesson. Today's lesson is on mean, median, mode, and range. Today's lesson was prepared by Mrs. Dean. Mean, median, mode, range. Hey, diddle, diddle, the median is the middle. You add, then divide for the mean. It's the average. The mode is the one that appears the most. And the range is the difference between. So this rhyme is supposed to help us remember how to calculate the mean, median, mode, and range. It will help us. Hey, diddle, diddle, the median is the middle. You add, then divide for the mean. It's the average. The mode is the one that appears the most, and the range is the difference between. Objectives. Students will be able to calculate the mean, median, mode, and range. Justify your answers by giving one reason. Evaluate problems with at least 95% accuracy. BJC question. Question number 1. Give the range of the heights of the 5 students above. Give the range of the heights of the 5 students above. We have 153 centimeters, 168 centimeters, 124 centimeters, 132 centimeters, and 177 centimeters. Remember to show your working. Good job, Marshall. Good job, Pinder. Good job, Sands. Good job, Jones. Good job, Campbell. Good job, Thompson. Check your answer, Etienne. Good job, Monroe and Cunningham. Okay, what about B? Give the median height of these 5 students. Give the median height of these 5 students. Good job, Marshall. Good job, Pinder. Simmons. Good job, Irvin. Yes, that's the answer, Ricardo. Okay, let's reveal the answers. So the range. To calculate the range, we subtract the least height from the highest or the greatest height. The greatest height would have been 177 centimeters, and the least height was 124 centimeters. Therefore, the range equals 53 centimeters. Now, who can tell me the steps for the median? What are the steps to calculate the median? Arrange a number from least to greatest and find the number in the middle. Okay, so the median is 153 centimeters. So we understand how to calculate the range and how to calculate the median. Good job. Are we ready to move on? Okay, the temperature at noon on 5 days in January were on Monday, 6 degrees Celsius, on Tuesday, 6 degrees Celsius, on Wednesday, 3 degrees Celsius, on Thursday, 2 degrees Celsius, and on Friday, 2 degrees Celsius. Calculate A, the mean. What is the mean? Remember to show all working. Good job, Marshall. Ada, where's the working? Okay, now calculate the range. Good job, Pinder and Etienne. Calculate the range. Good job, Grace and Smith. Good job, Colin. Good job, Pinder, Thompson, Smith, Black, Knowles, Ivana, Cunningham, Strawn, and Simmons. Etienne check answer, please. Good job, Simmons. Good job, Vanessa. Good job, Williams and Delancey. All right, calculate the mode. Calculate the mode. Good job, Sands, Pinder, and Strawn. Okay, let's reveal our answers. To calculate the mean, we add the temperatures. 6 plus 6 plus 3 plus 2 plus 2 gives us a sum of 19. Then we divide by the number of atoms. There are 5 atoms. As you can see, we cannot get any group of 5 out of 1. Therefore, place the 0. 5 times 0 is 0. Bring down our 9. We can get 3 groups of 5 out of 19. 5 times 3 equals 15. We have 4 left as a remainder. Therefore, we add a decimal point. Bring down a 0. Now, how many groups of 5 can we get out of 40? We can get 8 groups of 5 out of 40. 5 times 8 equals 40. Therefore, our mean is 3.8 degrees Celsius. The range. To find the range, we subtract the least temperature from the greatest temperature. That is 6. Subtract 2. Our difference is 4. So the range is 4 degrees Celsius. The mode is the number that occurs the most or appears the most. 2 and 6. 2 and 6 appears twice. Therefore, 2 degrees Celsius and 6 degrees Celsius is our mode. Okay. Question 3. The chart shows the ages of 6 boys. Paul, 15 years old. Mark, 14. John, 16. Michael, 13. Todd, 14. And Eric, 12. Calculate the total age of the boys. What is the total age of the boys? Okay, now calculate the average age of the boys. Calculate the average age of the boys. Okay, let's reveal the answers. So to calculate the total age of the boys, we add 15 plus 14 plus 16 plus 13 plus 14 plus 12, which is 84. Then the average age of the boys, we divide 84 by 6. We can get one group of 6 out of 8. Therefore, we say 6 times 1 is 6. 8 subtract 6 equals 2. Let me bring down 4. How many groups of 6 can we get out of 24? 4 groups. 6 times 4 equals 24. Therefore, the average age of the boys is 4. Next, calculate the modal age of the boys. What is the modal age of the boys? Good job, Hannah. Mark, Pinder, Delancey, Knowles, Thompson, Marshall, Robinson, and Etienne. Okay, now calculate the range of the boys' ages. Let's reveal the answers. The mode is 14 years. 14 appears twice, and the range is 4 years. 16 subtract 12 equals 4. Remember, to calculate the range, it's the difference between the largest or the greatest value and the least value. So 16 is the greatest age, and 14 is the least age. 12 is the least age. Therefore, 16 subtract 12 equals 4. Question: which two boys' ages are the same as the average age of the group? Good job, Cunningham and Skater, Clark, Smith, Capron. Good job, Lindina, Knowles, and Swain. The answer is Mark and Todd. Mark and Todd ages are the same as the average age of the group. Are we ready to move on? Okay. Question 4. The mean age of 5 children is 9. Calculate the total age of 5 children. The mean age of 5 children is 9. Calculate the total age of 5 children. Remember to show your working. Good job, Delancey, Neymar. Check your answer, Knowles. Good job, Gomez, Gator, Ivana, Howden. Check your answer, Campbell. Good job, Sands. Good job, Ayana. Check your answer, Bullock and Carey. Good job, Williams. Good job, Swain and Cunningham. Good job, Taylor. Okay. There's a part B to this question. 4 of the children's ages are 10, 8, 9, and 6 years. Calculate the age of the 5th child. 4 of the children's ages are 10, 8, 9, and 6 years. Calculate the age of the 5th child. Okay, before I reveal the answers, let's go back to question A. A lot of you told me that the mean age is 45. How did you get 45? Okay, good. By multiplying 9 and 5. 5 times 9 equals 45. Good. So our mean age of the 5 children is 45. At least the total age. Total age of the 5 children is 45. And they gave you 4 of the children's ages. What do you think you're going to do? Which operation are you going to use to calculate the age of the 5th child? Yes, it's 2 operations. What's the first one? Yes, addition is the first operation. What's the second operation? Subtraction. Good. What am I adding? The 4 ages. What is the sum of the 4 ages? Good job, Taylor. Check answer, Williams. Good job, Smith. Check answer, Walker. Good job, Ivana. Campbell, Etienne. Check answer, Anderson. Good job, Sands, Marshall. Carey, Taylor. Ayana and Shanton. Good job, Smith, Pinder. Good job, Walker. Okay. The sum of their ages is 33. Now we're going to subtract 45 from 33. What is 45 subtract 33? Okay, let's check our working. For question A, the total age of the 5 children is 45 years. You multiply the mean by the number of children to calculate the total of the 5 children. 9 times 5, like we said, is 45. And B, add the 4 children ages. 10 plus 8 plus 9 plus 6 equals 33. Then our second step is to subtract the sum of the 4 children's ages from the total ages of the 5 students. 45 subtract 33 equals 12. Our answer is 12 years. We were correct. Okay, let's try question number 5. The mean age of 6 children is 11. Calculate the total age of 6 children. The mean age of 6 children is 11. Calculate the total age of 6 children. 4 of the children's ages are 14, 13, 9, 10, and 7 years. Calculate the age of the 6th child. Good job, Smith, Dante, and Irvin. Good job, Carrie, Sands, Taylor, Davis, Marshall. Okay, let's reveal our answers. The mean ages of 6 children is 11. Calculate the total age of 6 children. So we said 11 times 6 equals 66. Therefore, the answer for A is 66 years. Question B. 5 of the children's ages are 14, 13, 9, 10, and 7. Calculate the age of the 6th child. We would have found the sum of the 5 children ages, which is 53, then subtract 53 from 66, which gives us a difference of 13 years. Good job to all of you who would have been paying attention and answering the questions correctly. Does anyone have any questions at this time about mean, median, mode, or range? What is your question, Boleg? What is the range? Can someone answer that question? What is the range? The range is the difference between the largest and smallest number. Okay, great job, students. Our next class it's Monday at 9 o'clock, God's willing. Stay safe and have a wonderful weekend.
Hi kids, today we're going to be looking at probability. What is probability, you may be asking? Probability is the likelihood of an event or outcome happening. And we use this formula whenever we're trying to find the probability. The number of desired outcomes over the number of possible outcomes. And I'm going to explain. And here we have a chart that is showing us and explaining to us probability. The first circle, it has equal chance. Here's what this means. You have green, blue, red, and yellow. That means you can either choose yellow, green, blue, or red because each of them is only there once. They're only there once. The second circle has more likely. It's more likely to choose blue than green. Here's why. There's more blue in your circle than green. The third circle says less likely. It's less likely to get blue because there is more yellow than blue. The fourth circle has 50-50 chance. That means there's an equal chance of you choosing blue or green, because each of them is only there once. Half and half. The last one says impossible. It's impossible to get any other color than blue because only blue is there. Now, when you're doing probability, your answer can be written in two ways, 3/4 or 3 out of 4. Now, just like with fractions, we know this is called the denominator and this is called the numerator. When you're trying to find your denominator, just like with fractions, you are going to add up or count how many are there in total, and that will give you your denominator. And then this 3 out of 4 is your desired outcome. So that will give you your numerator. And here we have an example with socks. The question says, what is the probability of choosing a green sock? So here's the trick for doing probability. Anytime you get probability, you always find out how many items you have in total. So we need to count how many socks are there in total. 1, 2, 3, 4, 5, 6, 7, 8. So I realize we have 8 socks in total. So I need to put that on the side so that I can remember that. Now, I need to go back to my question and figure out which color they asked me for. They asked you for green. So we need to go back to our socks and figure out how many socks are green. So let's go through each one. We're going to start with the blue sock here. That's not green. The second one is green, so we're going to circle that. This is not green. This is not green. This is green. This is not green, this is not green, and this is not green. So we have 2 socks that are green. Remember, when you're doing probability, you can write it 2 ways. 2, because we have 2 green socks. And anybody remember how we get our denominator? You count how many socks are there in total, like we did at the beginning, and we realize there are 8 socks in total. So that should be 2 over 8. Or you can write it the second way, 2 out of 8. Here we have a spinner, and it says, what is the probability of picking the color green? So we have green again. The same thing applies. We have to figure out how many spaces are on the spinner. That's what we have to count. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. So in this spinner, we have 8 spaces in total. So we're going to put that number there so that we can remember. We go back to our problem and we try to figure out which color are they asking us for. They are asking us for green. So we need to go back to our circle now and count how many spaces are green. So let's count green only. 1, 2, 3. So we see that we have 3 spaces that are green. So we're going to write our answer as 3 over 8 or 3 out of 8. And you can choose whichever way you want to write your answer. Next, it says, what is the probability of picking the color red? Again, we have to count how many spaces we have in total. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 spaces in total. Go back to your problem and see what they are asking you for. They are asking you for the color red. Go back to your spinner now and figure out how many red you have on your spinner. You only have 1 red. 1 red. So your answer should be 1 over 8 or 1 out of 8? Remember, you're not writing all two of them. You choose whichever way you want to write your answer. Next, it says, which color has the greatest probability of being chosen? Here is where you have to actually look at your spinner properly, and you're trying to see which color is on your spinner the most. Which color do you see the most of? So we're going to go through all. Here we only have one red. Here we have two yellow. So that's two yellows. Here we have two blue. Here we have 1, 2, 3. 3 green. So which color do you have the greatest probability of choosing? If you said green, you are correct. Green because it is there the most. If they had asked which color has the least probability of being chosen, which color do you think you would say? If you said red, you are correct. It's red because it's only there once. So that has the least probability. The one with the greatest probability is the color that you see the most of, and that's green. So here is a different example now. Instead of colors, we're looking at numbers. And it says, what is the probability of the spinner landing on the number 5? The same rule applies for when we did the spinner with the colors. You have to look for the number 5. So we're looking for our number 5 because that is what our question asked us. So we see that we have how many 5s? 1, 2. We have 2 5s. So we're going to put that there just as a reminder. Now, just like with the spinner with the colors, you have to count how many spaces you have there all together. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 spaces in total. And a little trick for you is you can either make a little dot so that you do not count a space more than once. So we have 9 spaces here in total. And the question says, what is the probability of the spinner landing on 5? We already know that we have 2 5s. So your answer should be 2 over 9, or if you chose to write it in the other form, 2 out of 9. Remember, it's up to you how you want to write your answer. Let's look at the next problem. What is the probability of the spinner landing on the number 3? The same rule applies. Anytime you get probability, count how many spaces you have there in total before you do anything. So let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. We know we have 9 spaces. My question is asking us for the probability of the spinner landing on 3. We have to ask ourselves, how many number 3s do we have there? 1, 2, 3. So my answer is 3 over 9, or 3 out of 9. Now, before we end this, I want to ask you a question. What is the probability of choosing the number 1? Again, you look to see how many number 1s you have. You know how many spaces you have in total. So if you said 2 out of 9, you are correct. Now, for this example, it says, what is the probability of the spinner not landing on the number 3? And our key word here in this problem is the word not. So we're going to underline that so that we remember we're looking for not the number 3. Again, you have to find out how many spaces you have in total. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, we have 9 spaces in total. Now, our problem says, what is the probability of the spinner not landing on the number 3? You can do this 2 ways. Let's see how many number 3s we have. We have how many number 3s? 1, 2, 3. So we know we have 3 number 3s. Now, you can either subtract the number 3 from your total 9, or another thing you can do is just count how many spaces do not have the number 3. So let's count. 1, 2, 3, 4, 5, 6. So your answer for this problem is 6 over 9, or 6 out of 9. Remember, your clue word there is not 3. So you're telling me with this answer there are 6 spaces that do not have the number 3 in it.
Howdy, boys and girls. Hope you're doing very well today. And welcome to another lesson with Mrs. Theophilus. Today we'll be getting an introduction to capacity. The objectives of today's lesson are as follows. We will define the term capacity, and we will compare the capacity of objects. Are you curious as to what is capacity? Capacity is the maximum amount that something can hold. Wow. Let's look at a few containers. The first container is a 5-gallon bottle of water, and then we have another smaller bottle of water and a cup of water. The 5-gallon has 5 liters, the bottle of water has 1 liter, and the cup has 250 milliliters. So will each of these containers hold the same amount of water? No. Let's look at a glass of water versus a bucket of water. Interesting. Now, do you think they will hold the same capacity? Of course not. Which one will hold more? The bucket, of course, will hold more. Excellent job. Let's do a little bit of practice, boys and girls. Let's compare more than or less than capacity. If we look at the first one, the ice cream tub holds more than or less than the plastic cup. What do you think? That's right. The ice cream tub holds more than. So we're going to write more than on the line. And I love ice cream. Excellent. Let's look at the second one. The bucket holds more than or less than the book tray. That's right. The bucket will hold more than. Do you know how heavy those buckets are when we fill them up with water? And then we have to tote them inside? Oh my gosh. Let's look at the last one. The plastic cup holds more than or less than the water bottle. The plastic cup holds less than. Very good. Excellent job. You're getting an idea how to compare capacity. Very good. Thank you for your attention, and I hope you have an idea about what is capacity. Have a great day, boys and girls, and as you go throughout your day, drinking from cups and eating from bowls, remember to observe their capacity. Bye-bye. Hello, boys and girls, and welcome to another lesson with Mrs. Theophilus. Today, we are going to learn about capacity. In today's lesson, we are going to estimate the capacity using liters and milliliters. We're also going to differentiate liters and milliliters. Measuring capacity. Capacity is a measure of how much space something takes up. Capacity can be measured in units, such as milliliters or liters. A medicine dropper holds about 1 milliliter. A water bottle holds about 1 liter. A water glass holds about 250 milliliters. We can use a measuring cylinder that has milliliters to measure very small capacities, like a can of soda, for instance, or a small baby bottle, small carton of milk, or a small container of liquid soap. All of these items have small capacities, and so we would measure them using milliliters. Now, when we measure larger capacities, we would measure them using liters. How would we measure the capacity of this container? A container of gasoline is measured in liters. How would we measure the syrup? A bottle of syrup is measured in milliliters, as this is a smaller amount. How would we measure this jug of laundry soap? A jug of laundry soap is measured in liters, as this is now a bigger amount. It has a bigger capacity. Let's do a little practice. Let's see which objects do we measure liters or milliliters. If we're measuring the capacity of the water in a pool, we measure that in liters. If we're measuring the capacity of a spoon of medicine, that's a small capacity, so we'll measure that in milliliters. And a tub full of water, if we were to measure that, that's a large capacity, so we would measure that in liters. Enjoying a liter of water. Refreshing. Thank you so very much for your attention today, boys and girls, and I hope that you're going to practice your measurement with capacity.
Cardiovascular diseases, diabetes, cancer, and chronic respiratory diseases are known as non-communicable diseases. In recent years, these diseases have increased as a result of population aging, urbanization, globalization, and changes in lifestyles, and they've become the great epidemic of our age. Non-communicable diseases can largely be prevented by adopting a healthy lifestyle, but to do so requires more than simply personal determination. For example, when wholesome food is more expensive and less available than junk food. When physical activity is a challenge because the parks and recreation areas are not safe or properly equipped. Or when it's hard to quit smoking or drinking because advertising of these products seems to be all around us. That is why laws and regulations are needed to make the healthy choice the easiest choice. Without these laws and regulations, more and more people will develop a non-communicable disease and need lifelong treatment that could ruin them financially. But there's still time to stop this epidemic from growing, and some countries in the Americas have already taken action by, for example, reformulating processed foods to make them healthier, informing consumers about the nutrition content of packaged foods, making more fresh foods available, regulating the sale of junk food in schools, as well as providing free drinking water, increasing taxes on tobacco, alcohol, and sugar-sweetened beverages, facilitating access to quit smoking programs, banning tobacco use in enclosed public spaces, and limiting the advertising of cigarettes, alcohol, and junk food. Creating opportunities for physical activity, including creating recreational bicycle paths and promoting the use of public transportation. Governments should ensure access to health services for its population, including access to early detection of disease, diagnosis, medicines, and treatment provided without discrimination and without undue financial hardship. People should be provided with information and support that empowers them to manage their own health, giving them greater control over their health and contributing to the health of their families. This way, all together, we can stop this terrible epidemic from getting worse and enjoy longer, more productive lives. Healthy public policies and healthy lifestyles are the prescription to prevent and control non-communicable diseases. Please share this information, and if you want to find out more, visit our website.
It is normal to feel overwhelmed, lonely, scared, or sad during a crisis. Coping can be difficult when your daily schedule is interrupted. Drinking may feel good, but is not the best way to cope with stress. It can worsen your mental and physical health and impact your family. So how can you cope? Keep physically active, like taking a walk or dancing. Cook and eat nutritious food, including fruits and vegetables. Engage in indoor activities like playing games and staying connected with family and friends. Meditate, encourage yourself, or enjoy music. Still feeling overwhelmed? We are here to listen. This message is brought to you by these partners.
Depression among older people is common. It is often overlooked. Loneliness and loss of independence are causes. Depression can be treated. The first step is talking.